Welcome back. Today I want to talk about loops. Now loops are essential in programming. Actually, that's the main reason why we do what we do, because now it's the computer's turn to do things over and over again without getting tired. So today I want to talk about different types of loops and looping over different objects. The first one we want to discuss is the so-called for loop using range. So for instance, I could write for, and I can now use any index. I just denote the index j in range maybe 10 and then colon. And indentation, so you go into a block. I make a simple print statement. I just want to print the index and see what happens. Now what this will do is it will print the index in range 10. And we see in a minute how that looks like. Of course, as always in the case of Python, you start counting from 0. So again, you note that 10 is exclusive. Yeah, so similar compared to the ideas we discussed before when we spoke about slicing. Now this is one way to loop. So we tell the computer you start at 0 because that's the default, and you go all the way up to 10 or any other number. Of course, you can modify this. You can have a start value. For instance, we don't want to start at 0. Run this again. You can modify this. You can also do further modifications, adding a third numeric into it, and now of course you see the step is changing. Yeah, so these things can be modified. So it's quite a nice tool if you want to use an index inside a loop for any kind of numeric operations, or you want to repeat a certain activity, a certain number of times. In most cases, the other very useful way to loop is to use an object over which you can iterate. For instance, a list. Or it could be another object which can be iterated over. Iterated over means indexing has to be permitted. Yeah, so indexing is essential because you have to know where you are in this loop. Good. For instance, we could have say different food items. I just call this foods, and I put this into a list, and we spoke about lists before. For instance, here I can put apples. I could do pizza, whatever you prefer, and some bread. Then we can do a for loop. So for food in foods, again I close this using the colon. I go into indentation, so I start a block, and I use a print function, and here I put the f in front, so it's a formatted string, and I, for instance, say I like to eat, and then I use the placeholder, which is the curly brackets, and I put in food. So what this will do is it looks at my iterable object, which is a list called foods. It goes through the list line by line, and it would put this food item into the sentence where we have the placeholder. So let's run this, and you see I like to eat apples, I like to eat pizza, I like to eat bread. This is basically how it works. Good, so these are, I would say, the most common loops we will use in the next sessions. The other thing which is important is the so-called while loop. A while loop runs until the statement you make is no longer true. And we spoke about booleans and how to construct them in previous sessions. So for instance, if we want to construct Fibonacci numbers, we can use a while loop to do this up to a certain value, for instance. So if you don't know Fibonacci numbers, just have a little Google and look around. So Fibonacci numbers are quite a nice exercise for while loops and other loops. So the idea of a Fibonacci number is you start at 0, always two numbers, the two previous numbers are added up to give the next number. Yeah, you see this is how it's constructed. For instance, the 3 results from 1 plus 2, the 5 results from 2 plus 3, the 8 from 3 plus 5, and so on. So these are Fibonacci numbers. So obviously we have two values which we have to add to get a third value. So we need, in our case, initial values. So we need two initial values based on the so-called recurrence relation. So I put these values, and this is entirely up to how you want to construct this, into a list. I start my Fibonacci numbers in a list from 0 to 1, and now I want to add things to the list. And of course we already know we can use the append method. So we append the list by one item. So for instance, what we can do here is we can do the following. We can append this list now by the next item, which would refer to the first item of the list. It's easier to use -2. So this is not the last, but the one before the last, and we use this in indexing plus the one which is in the last position, which is -1. Yeah, so this would do it. We do a little print function here. We can just see what happens. And you see now we add the next one to it. And of course now we can just continue this. We can do it one more time. For instance, and let me just run this, and you see the next number emerges, and so on and so on. We want to now keep doing this for an extended period of time, and of course it's no longer convenient to always copy-paste the command. So again, we have to be smart, and we have to use loops for that. So for instance, if the objective is to construct the Fibonacci numbers up to a certain value, and you can see the values here, let's say we go up to 10,000, we can do it as follows. We can use a while loop. So in here we can say while the last value in the list, so it refers to -1 using indexing, so while fib -1, so this is the last item on my list, is less than, for instance, 10,000. So as long as this is true, and now use indentation and get rid of this, I don't need that. So as long as this is true, keep appending my list with the last value of that list and the value before added up. And in the end, we do a print function for the Fibonacci numbers. Let's run this. And you see now it's working as intended, and you go up to 10,946. Yeah. So the last one goes above the 10,000, because what it does is every time it goes back to the while statement, it will actually check this condition. So the previous one would be 6,765. So this is less than 10,000. So the statement is still true. So it starts appending, which means it starts adding these two numbers to get to 10,946. Then the next round starts, and of course now the last item on that list is no longer below 10,000, so this statement is false. So once this condition is false, the while loop stops. One important thing to note is a while loop, if you're not careful, can go on forever. So of course that happens if the condition never ever is false. Yeah, so for instance, a nice joke is if you ask your friend, while you go outside, can you get me some milk? This friend, who is also a programmer, will never ever come back, because you don't break the while loop. Yeah, so always think about this. If you give instructions, be precise, make sure the while loop actually doesn't go into a loop that never ever ends.